we established in the preceding that the absolute value of x is less than or equal to 4, provided x is less than or equal to 4, and x is greater than or equal to negative 4. Again, being less than or equal to 4 doesn't necessarily make this true. Also has to be greater than or equal to negative 4. And being greater than or equal to negative 4 doesn't necessarily make it true. It's also got to be less than or equal to 4. So it has to be both. It has to satisfy both of these conditions in order to satisfy this inequality. That's the reason for the and. It has to satisfy this and satisfy this. Must satisfy this and must satisfy this. Now, for the absolute value of x is greater than 4, we've seen that as long as x is greater than 4, this is true. We don't need this condition to make this so. We don't have to add anything to this condition to say that if this condition is true, then x is a solution to this equation. The same here. This condition ensures by itself, without any reference to this condition, that if x satisfies this, that is, if x is less than negative 4, then its absolute value is greater than 4. So we could have either condition. We can't have both conditions because if it's 1, if it's greater than 4, it's not less than negative 4. So if it's one, it's not the other. And if it's this, it can't be this. And you should think that through for a minute. Okay, so x could be either. Okay, this condition alone makes it so. This condition alone makes it so. That's the reason we say or. Here we say and because x has to satisfy both conditions. Now, when we sketch the arrows representing this inequality and this inequality and this and this, we'll see just how the and the or can be interpreted in that case. Now, I can easily sketch the arrows. Okay, x greater than or equal to negative 4, we'd have an arrow that starts here and goes to the right. And x less than or equal to 4 means that what can be represented by an arrow starts here and goes to the left. Both arrows going on forever in their direction, but not going past the circled point. So the inequality says that the absolute value of x is less than or equal to 4, and we say it's got to be this and this, meaning x has to be on this arrow and x has to be on this arrow. So where are the points that make that so? Well, they're from negative 4 to 4, non-inclusive of the endpoints. Okay, so x is on the red segment. If it's on the first segment, the orange segment, and on the green segment. Okay, now I said something that probably confuses you a bit because it was completely incorrect and for an obvious reason. I put open circles here, 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 and here because I was thinking about that greater than inequality rather than the less than or equal inequality. X satisfies these inequalities if it's equal to 4 or to negative 4, depending on which inequality. So we do want to fill in these dots. And now the inequality is negative 4 less than or equal to x less than or equal to 4. That corresponds to the red segment, and the red segment corresponds to where these two segments overlap. This can also be written as a set union. So I'm going to write that down, then we'll talk about that. And I just said set union, and it's set intersection, as I know perfectly well. Need to think about my words before I utter them. Okay, unfortunately we don't have time to go back and edit and redo all this. So hopefully you understand what I mean. Okay, so this set can be indicated in interval notation as the set -4 infinity with a closed bracket on this end because we include -4. And speaking of closed brackets, this one ought to be closed. Let me see if I can close it without messing it up too badly. Yeah, that's not great, but we'll live with it. Okay, and then this green interval is the interval -infinity, -4, the half-closed interval, closed at the -4. And then the red interval, the interval corresponding to the solutions of the inequality, is the interval from -4 to 4, closed on both ends so that we include -4 and 4. And this interval is the intersection of these two intervals. I'm going to write that down. Do keep an eye on me. Okay, that's obviously -infinity to 4, -4 to infinity. So, again, the interval -4, 4 is the intersection of this set and this set. And I've written that down here. -4, 4 is the intersection of the interval -infinity 4 and the interval -4 infinity. Intersection means, in set theory, you should be aware of this, intersection means that an element must be in both of the two sets to be in the intersection. It has to be in one set and in the other. That relates the and to this statement that X must be in both to the whole picture of what all this means. Okay, now, the logic, the use of these words is actually pretty hard to understand because we're just not born understanding logic very well, and we never ever get very good at it. Now, we're smart enough that we can work out the rules of logic, a consistent set of rules that embodies exactly the way we think logic should behave. And that's a very consistent set of rules, and we can use those rules to break down complex logical statements and arguments. Okay? 3 or 4 steps of logic is enough to confuse most people. Add a couple more, it'll confuse anybody on earth without, if in the absence of the rules to sort things out. And at the 6 or 7 steps, nobody really understands what's being said. They just understand what the logic breaks it down to mean. Okay, so this whole thing about and or and union and intersection and everything is really important. If we don't understand this, we're not likely to understand much of anything about logic. And if you're finding this challenging, it's because it is inherently challenging. Even though these are very simple constructions, they take some getting used to and some understanding. Now, X is greater than 4. That's true if X is greater than 4. It's also true if X is less than 4. The absolute value of X will be greater than 4 under either of these conditions. So, everything on this yellow arrow that represents all the X values greater than 4, and everything on this purple arrow that represents all X values less than -4, with the open point at -4, open points at -4 and 4, because those points are not included because of the strict greater than. Okay, anything in here, any X in here is going to satisfy this inequality. Any X in here is going to satisfy this inequality. That wasn't the case over here. It's not true that any X on this arrow will satisfy the inequality. All the X's out here past 4 don't. Okay, so there are lots of X's on this arrow that don't satisfy it. The only ones that do are the ones that are also part of this arrow, giving us the interval as we've seen before, and telling us that we need to do the intersection of the two intervals. Okay, in this case, either this or this. That's why we say the or. Now, logical or means this or that or both. We don't care if both. As long as one of them is true, then the or is true. Now, in this case, it can't be both. If it was over here, if it was this or this, then everything would satisfy it. Anything out here would satisfy it because it's on this one. Anything out here would satisfy it because it's on this one. And anything in between would satisfy it because any point in between is on at least one of these. Turns out it's actually on both, but that's fine with OR. Okay, so in this case, we just have these two intervals, and that is the whole solution set. Now I'm going to write out the intersection and another statement. So my statement is X is in the red set, and I've shaded the entire set in red, this interval and this interval, and I guess I should probably indicate the open points at -4 and 4. X is in the red set if X is in the yellow interval or in the purple interval, and looks like I left the R out of purple. Kind of in there crooked, but it's in there. Okay, so that means since X again is in the red set, the set that we're looking for, the set of solutions, if it's in the yellow interval or the purple interval, and the red intervals that I've drawn here, two red intervals, embody both of those, and the set we would write as the union of the set -infinity, -4, and 4, infinity. Now I believe everybody will understand what I mean by these two sets, since they're so similar to these sets in the notation, but I've gone ahead and indicated very clearly that this set is the set -infinity, -4, and this set over here is the set for infinity. This set is the solution to that inequality. Now I've written in the statement, this set, meaning this set here, is the solution to the inequality absolute value of X greater than 4. And I've also written in that indicated that either this or this is the solution to absolute value of X less than or equal to 4. And then just to be complete, I've written definition of union. It's not really a complete definition, but it's an indication that embodies the complete definition. Something is in the union if it's in at least one of the two sets. Again, in the intersection, it must be in both sets. Therefore, the OR applies to the union and to this situation. The AND applies to the intersection and to this situation for the reasons we've seen.